So we've pretty much really looked through how do we graph equations and what do the different equations look like. We talked about slope-intercept, we talked about point-slope, we talked about standard form, finding the x and y intercept. We're going to now move to, and that would be graphing equations with two variables. So what we're going to look at now is how do I graph inequalities with two variables. Now to do this, I'm going to do a quick review on how we graphed inequalities with one variable. So I've got, let's say I had x is greater than 7. Well, to do that, I would have to, if I have one variable, I would use one number line here. And I would just put this on a number line because think about what this means. That means x is everything more than 7. I can't list out all those values, so what I do is I draw a picture to represent. So let's say I do 6, 7, and 8 on my number line, just to show 6 is less, 8 is more. I do an open dot because I am not including 7. I'm including everything up to 7, or I'm including everything, everything greater than 7, but not 7 itself. And then to show that this goes on and on forever from that 7, I use a ray because it's going on forever in one direction. So I use a ray. And that goes that way. The only little wrinkle here was as if this was greater than or equal to. Because if it's greater than or equal to, that means I'm including 7, so the way I show that is I fill in the dot. And if this switched around and was less than, I would just point the ray the other way. So a couple things. One variable means it goes on forever in one direction on one number line. So think about what it would look like for two variables. So here I've got y is greater than x plus 1. Okay, so let me zoom in here. Now we know how to graph the line y equals x plus 1. So what I'm going to do first is I'm just going to graph that. Y equals x plus 1. Well, on this, I know my slope is 1. I know my y-intercept is 1. So I'm going to start at 1, and I'm going up 1 over 1, up 1 over 1. Just like that. Now here's the deal. Think about what this inequality would mean. For an inequality, I'm looking for solutions. I'm looking for things that work. So on this, on a line, the solutions for y equals x plus 1 are just every point on this line, right? Well, if I have y is greater than x plus 1, the solutions I would be graphing here are the ordered pairs that work. Well, where are the ordered pairs? Well, here's an ordered pair, and here's an ordered pair, and here's an ordered pair. There's ordered pairs at every point on this coordinate plane. The question is, which ordered pairs are solutions for y is greater than x plus 1? So to do that, we kind of have to take a test point. So what I'm going to do is I'm going to take 0, 0, and I'm going to plug it in and see if it works. Just like, remember I told you when you graph one variable, you take, if it was x is greater than 7, I would take 6 and I would take 8. Well, 6 is not greater than 7, so obviously we don't go through 6, we go through 8. So here, if 0, 0 works when I plug it in, so I'm going to plug in 0 for y, and I'm going to plug in 0 plus 0 in for x. So all I did is I plugged it for y, I plugged in 0, for x I plugged in 0. So I'm going to see if this ordered pair works, okay? So what I have here, I have a dividing line, a boundary line. Just like my dot when there's one equation, one variable, my dot is my boundary line. Here, my boundary line is a line. And I'm either going to have solutions on this side of the line or on this side of the line. I got to figure out what side of the line my equations are on. Well, if I solve this out, I have 0 is greater than 1, which is not true. That means that this is not a solution. So what that means is I'm going to shade in. So all my solutions are over on this side, right? And there's so many of them that really if I were to put a dot at every solution, it would just look like this. It would be all shaded in. So we shade in, and I'm shading all the way up to that line. We shade in everything that works. Now, here's the other part of this. Here's the other wrinkle. I graphed y equals x plus 1, but you'll notice this says y is greater than x plus 1. That means y does not equal everything on this line. So if I take a point on this line, let's say I take 0, or let's just take this point right here. Let's take 1, 2. So 1, 2 is on that line. So let me plug in y equals 2 and x equals 1. So I'm going to say 2 is greater than 1 plus 1. Well, that's not true. 2 is not greater than 1 plus 1. It's on the line, but that doesn't mean it's a solution. So for my line, what I'm going to do, remember when it was y is greater than 7, I put an open dot. When it was greater than or equal to, so when we included 7, I filled it in. So to show that on a line, that was just one variable. Now I've got two variables, right? Just that on a line, instead of doing a solid line, I'm going to do a dotted line. Okay? So the dotted line shows that all the solutions are everything up to this line, but not on the line itself. Okay? So that's how we graph. And a couple things I want to point out. You'll notice that with one variable, I needed one number line. Now with two variables, I need two number lines. With one variable, my solutions were all the numbers forever in one direction. So we had array, because array starts at a point, at an endpoint, and goes on forever. With a line, or with two variables, I use a line because it's on forever in two directions, okay? And I've got to shade the region rather than just using the ray, okay? So let's look at a couple others here. So there's that one. All right, let's look at y is less than or equal to x plus 1. So once again, I'm just going to graph x plus 1. Now you'll notice I am including x plus 1 here. So if I plugged in, remember how I plugged in down here? I plugged in 1, 2, because 1, 2 was on the line. So if I did that again, if I said 2 is less than or equal to 1 plus 1, that is true. 2 is less than or equal to 2. That works. So rather than doing a dotted line on this, I'm going to do a solid line, okay? So my y-intercept is still at 0, 1, and I'm going up 1 over 1, because my slope is still 1. And I'm going to connect the dots. And then I've got to decide which way do I shade, because you notice there is a slight difference here. The last one I did y is greater, this I did y is less. So look at the difference between y is greater and y is less. Well, if y is less than 1, and I plug in here, let's see, I plug in 0, 0 again, right? So I do 0 is less than or equal to 0 plus 1. Well, now, that's true. 0 is less than 1. That means that I need to shade everything on this side of the line. Because 0, 0 is a solution. That means everything that's on the same side as 0, 0 is also a solution. So that's the region I shade in for this one. Okay? All right, one more. And then we'll be done. On this one, you'll notice it's not in slope-intercept form. So a couple things to point out here. This is in standard form. So probably what I'll do here, it's going to be pretty easy. See, I have 3y, 4x, and 12. It's going to be pretty easy to find the intercepts. So I'm just going to do x and y intercepts here to graph this thing. So I will let y be 0 and I'll let x be 0. Well, when y is 0, so I've got 3y plus 4x plus is let's just say equals 12 to get my solutions, right? We could put the inequality in later. So if y is 0, I've got 4x equals 12. So x equals 3. Okay, that's if y is 0. If x is 0, that crosses out that. So I'm left with 3y equals 12. So y equals 4. So I'm going to graph. I'm going to put a dot at 3, 0. I'm going to put a dot at 0, 4. The next thing to point out, so I've graphed some dots. I need to decide what kind of a line I need. Notice this is less than or equal to. That means I need a solid line, not a dotted line. So I'm going to go, just graph this one. Whoops, that's terrible. Let me try and connect that better. Something like that. Okay? Now, I'm not done. I've just graphed the line. To do the inequality, I need to shade one side or the other. So again, if I have 0, 0, the only time you can't test 0, 0, I pick 0, 0 because it's really easy to test. The only time you can't test 0, 0 is if the line goes through it. And in that case, you can test anything you want. You could test 1, 1. You could test negative 3, 3. You could test anything, really. So if I test 0, 0 here, I'll say 3 times 0 plus 4 times 0 less than or equal to 12. Well, that's 0 plus 0, and 0 is less than or equal to 12. That's true. So that means I just need to shade everything on this side of the line. Because 0, 0 is a solution, that means that all of these, everything on the same side as 0, 0 is on the winning side. Okay? There you have it. That's how you graph the inequalities. Go ahead and practice this. Take a little bit of practice. Just remember a couple things. What type of line do you need? Opener or a dotted or solid. Okay, and that depends on, is it less than or greater than, or is it or equal to? Okay, and then what region do you shade? You can test 0, 0 if the line doesn't run through it. You could test any point though. If the point works, that's the winning side. If the point doesn't work, if it's not a solution, like it wasn't a solution here, then the other side is the winning side, and you shade that in there. Let me know if you have any questions.